Okay, before we start going over the homework, let's just go over just briefly how to simplify radicals, all right? Because we didn't really cover that. Now you did in Algebra 1, but usually in Algebra 1 Algebra 1 teachers normally don't take a whole lot of time going over that stuff. In Algebra 2 you'll do quite a bit of that stuff, and we do a little bit in here. Allie had a question on the test. Will I require you to write it as a simplified radical? I probably won't. All right. If I'm teaching Algebra 2, though, and it's the chapter on simplifying radicals, then you have to simplify the radical. Does that make sense? But this is geometry. You have several different ways you can write the answer. So I'm not necessarily trying to teach you how to simplify radicals, in this section. I just want you to get the right answer to find x, y, and z. So I probably will not, but let's just do it anyway. Show you how to simplify the radicals so that when you do get to Algebra 2, at least it won't exactly be fresh in your mind, but at least it'll be in your mind somewhere, right? And then you can recall it and say, oh yeah, I remember Mr. Hamrick went over that stuff, okay? So, for instance, what do we start off saying? We start off doing real easy ones, right? Square root of 25, you all know what that is, right? Square root of, let's say, 49, what's that? That's 7. And there's a whole bunch of them you know, right? Square root of 121 is what? 11. Okay, so we're good with that stuff. It's where you get into the ones that don't come out exactly even, or the ones you have trouble with. Agree? Alright, so there's several different ways to do it. On a problem like this is how I would do it. Sometimes you could break it down all the way into its primes, to its prime numbers. You know what I mean? Yeah, and you could do that, and that's perfectly fine. I'll just show you. Let's do it that way once, and then I'll show you a little bit of an easier way to do it, okay? So if you broke it down into its primes, what do you got? You got 5 times 10, right? But then you take 10 and break that down, what do you get? 5 times 2, right? Would you agree that that's 50? Right. Okay, so if you have a square root, what you do is this. You look for a pair of the same numbers. Okay, you have 5s and they're together, aren't they? So what if I multiply those together? It's 25, right? What's the square root of 25? It's just a 5, isn't it? So anytime you pair them up, you don't even have to go through that process of going 5 times 5, what's the square root of that? You could just look at it like this. This is the same as 5 squared, isn't it? Okay, and if I take a square root of a squared, what happens here? They just cancel out, and what am I left with? Just a 5, okay? And that's kind of nice. Now that was easy. 5 times 5 is 25, square root of 25 is 5. That's simple. But what if, now you probably won't have it, but what if you had like 17 times 17 times 2? Like 17 times 17, is that a number that pops up in your head? No, and then you get some big old crazy number, then you got to take a square root of that crazy number, right? That'd be a pain. But you realize what? 17 times 17, right? And take the square root, what does that come out to be? That just comes out to be 17, doesn't it? You follow me? And so this would be 17 square root of 2. You follow me? So this would just be what? 5 square root of 2. Okay, then you just multiply them together. So let's say we had a 5 times 5 and a 3 times 3 and a 2, right? So whatever that number is, I don't know. I don't really care. But it's some big old number, right? And I broke it down into its primes, and this is what I got. So how would you simplify it once you get to this part right here?
15 square root of 2.
It would be. Right. This would be a 5. Let's just do the intermediate step here. This would be a 5, correct? And it's not inside the square root anymore, is it? It comes outside of the square root, becomes just a 5. This, it's a square root of 9, which is 3, or it just comes out of the square root and becomes a 3, and you multiply those together. Remember, that's outside of the square root. What's still left inside the square root? The 2. So what is that? This is 15 square root of 2.
Now what if you solve 15 square root of 2 and you just do the opposite way?
What do you mean solve for it? I mean, it's already solved for. It's already simplified.
Will they ever give you a problem and give you 15?
Not like that, but for like next year, if you want to like get it back to like.
Oh, they're not going to ask you to get it back to the thing.
They wouldn't.
Like I was trying. Remember, I was doing this in my head.
Yeah.
I mean, what did I do? It's like I went 15 squared, right? If I wanted to stick that 15 back inside the square root, I would have to square it to put it back here. So 15 squared is what, like 225? And 225 times 2 is whatever that is, 450. So that's 450. No. This is the simplest form right here. They're always going to have you take it from, oh, what did we say it was, 450? Okay. So the square root of 450 would be the same thing as 15 square root of 2. Did we do the math right? Double check that. 25 times 9 times 2. So let me do that real quick. Well, we can do that. 25 times 2 is 50.
It
Times
is.
9 is 450. Yep. So would you agree with that? So you could go back to this, and that's what I was doing in my head. When I was reading them off, it didn't have this in the book. I was trying to do that, figure that out in my head. But they did give you this right here, and they gave you a decimal. So on the test, on a quiz, can you put that into a calculator? Sure, I guess you could. You could just go square root of 450, right? Put it in the calculator, and you get about 21.2. 21.2. Is that the same thing as 15 square root of 2? Well, let's see. 15 square root of 2.
Wait, how do you do that?
Same exact number, isn't it? I mean, it's not just close, it's exactly the same. So would you agree that the square root of 450 is the same exact thing as 15 square root of 2? Absolutely. All right. Does that help a little bit?
Yeah.
You guys did a little bit of that in Algebra 1, didn't you? Okay. All right, so you got that. You got that in your mind. Now, what I would do is this. When I saw the square root of 50, I didn't think of breaking it down all the way to its primes. I'm thinking of a number that I can take the square root of, a perfect square. You ever hear that? Okay, I'm trying to think of a perfect square that's in that 50. Like 5 times 10, but is 5 a perfect square? Is 10 a perfect square? No. What else multiplies to be 50? 25 times 2. Is 25 a perfect square? Yeah, because I can take the square root of 25 and come out to a nice whole number. Does that make sense? So when I'm doing this is what I'm doing. This is what I'm thinking. I'm thinking kind of like a step ahead. I don't go all the way down to the basic number, to the prime numbers. I'm thinking, 25 times 2 is 50. What's the square root of 25? It's just 5. What's the square root of 2? It's just the square root of 2. And that's how I would do it.
So you could get 5
Okay.
square root of 2?
Yeah,
Oh.
so square root of 50 is the same exact thing as 5 square root of 2. No. It's a decimal number. It doesn't come out even. Okay, so you just leave it the square root of 2. Okay?
How do you do that thing on the calculator where you do 15?
You do 15.
Well, it depends on your calculator.
15 times square root of 2 equals.
Yeah, if you have a TI 30XA, you'd hit 15 and then times, and then you'd hit 2, but then you'd hit square root. What just happened? You just took the square root of the last number you just entered, right? Then you hit equals and you'll get the same exact thing. Exactly what I got. Different calculators, but you got the same exact thing. Make sense? What if you had the square root of 40? Now, you could break it all the way down to its prime numbers, but what would you use? What times what? Would you use 8 times 5?
I would use 4 times 10.
I would use 4 times 10. Why? Because 4 is a perfect square, isn't it? Okay, I can take the square root of 4 and come out to a nice whole number. So you could actually do this in your head, but watch. Here's your brain right here, okay? This is what I'm doing in my brain. I'm thinking 4 times 10, right? And what's the square root of 4? It's 2, and what's left over? Square root of 10. Can I break 10 down any further? No, I can't, all right? So if you see this, you might be able to go directly from this, do a little bit of this in your head, and just say, 2 square root of 10. Does that make sense?
Wait, can you do it in the prime number?
Because 2 times 5. 2 is prime and 5 is prime. So you can't combine anything together anymore. What if you did it this way? What if you went 8 times 5? Watch this. Can you take the square root of 8 and come out to a even number? No. Can you take the square root of 5? No. But you can take 8 and do what to it?
Break it down.
You could break it down even further, can't you? Do you see that? So this is what? 4 times 2 times what? Times 5. Now, well, I can take the square root of these things. I can take the square root of 4. What's the square root of 4? It's just a 2. And then that goes away. Can you take the square root of 2 and come out to an even number? No. Can you take the square root of 5 and come out to an even number? No. So what do you do with those two? Just multiply them together and you get 10. I mean, you could have something like this. Watch. Like that. You could have something like... Is that what you're talking about?
No, if you got like a situation where like the outside number was like 625 because it was like this huge number.
Like the number on the outside was 625?
Yeah, but it can be reduced down to 25 even
If it's not under a square root, you can't. If it's outside... Yeah, if it's outside the square root, you can't break that down because it's not under a square root.
Like 16, you don't lose it for.
Right. Yeah, if this is like 16 square root of 3, you don't take the 16 and break it down anymore. It's
Okay.
already a whole number.
Okay.
You can only break it down if it's under a square root. Like right here. Let's do this one right here. So it's 2, right? Put the square root.
It's 4.
What would you use here? Now, 8 times 4 is 32, right? And 4 is a perfect square, and you can take 8 and break that down, but there's a better number, though. What's the better number? 16 times 2, right? So it's nice to know, you know, some of your multiplication tables and things like that, because it makes things a lot easier.
So then you break down.
And then you'd break down to 16. That 2 is being multiplied, right? That 2 just stays 2. This right here becomes a what?
8.
A 4. It's a square root.
So it would
Okay,
be
it's the
8
square
times
root.
2.
Right, and then so that goes away, doesn't it? It doesn't go away. It turns into a whole number outside. And then you're left with a square root of 2. You can't break that down any further. 2 times 4 is 8, square root of 2.
Okay. I just wasn't sure if you wanted us to like outside.
Now, you can't simplify it. It's already as simplified as it can get. Now, you may have a number that it might have to multiply by, right? There you go. Make sense? Okay, let's do one of
Can we
these,
do the first homework one?
the very first one.
No, not the first one. Like the first.
21.
Yeah.
Okay, 21.
Do them.
I'll tell you what, let's do a real basic one first, and then we'll work our way up to it, okay? Because I've got some time. All right, well, let's do it anyway, because not everybody did. So, it's not exactly right angle, but it's close enough. So let's just start real straightforward, okay? Just so we get the idea of what we're trying to do here. And then we'll do ones that are a little bit more complicated. So this is y, this is x, and this is, whoops, z, right? And down here is a 4 and a 9. Now, it doesn't really get any easier than this one right here for this type of problem. Okay? Here's the deal. Go back and watch the video, I'm telling you, okay? Go back and watch it because I'll explain it, you know, and you can hear it 2 or 3 times in a row if you wanted to. But let's do the first one. This is the altitude. The altitude, is everybody listen now? The altitude is the geometric mean between the 2 segments of the hypotenuse. Did you hear what I just said? This is the altitude. You got to know vocabulary, okay? I'm saying it basically as flat out as with the least amount of words that I possibly could use, okay? As what? No, it's not dumbed down. It's straightforward, but you got to know what these vocab words mean, though, okay? So let me say it again. The altitude, this is the altitude, x, okay, is the geometric mean. Well, what does that mean to you? What is me telling you it's the geometric mean? What does that have to do with anything?
It was like on the top.
That's right. So if I said this is the geometric mean, that means that x is going to go here and x is going to go here. That's what we're solving for, okay? That's the geometric mean. So that's the geometric mean between 2 numbers, right? Between which 2 numbers? Between the 2 segments of the hypotenuse, right? This is the altitude, and it's drawn to the hypotenuse. This is the 2 segments of the big hypotenuse. Everybody see that? That's the whole big hypotenuse right there. Got it? And what is that big hypotenuse? But this is the...
Wait, how do you know it's 13?
Because that's 9 and 4. 9 plus 4 is 13. Okay, so this is the geometric mean between the 2 segments, or the 2 parts, if you want to say, of the whole big hypotenuse. Got it? So what do you put here? 9 and 4. And then you solve, right? Now you just do some math, cross multiply. X times x is x squared. Now watch what I'm going to do. You could go 36, but let me just show you a little trick. On this one, it really doesn't help, but there are problems that this little trick does help a little bit. Sometimes you'll get some big, huge number, but there are times where it's a little bit easier to keep it like this, because what are you going to do? You're going to take the square root, right? I mean, 9 times 4 is 36. You know what the square root of 36 is already, but watch. See if this works. You could just take the square root of 9, which is 3, and then the square root of 2, which is, I'm sorry, I gave it away. The square root of 4, which is 2, and then 3 times 2 is what? 6. Do you see that? Sometimes you don't want to multiply these together because the number gets really big and huge, and then it's a lot harder to simplify it. Sometimes, not this time, but there are some times where it's a little bit nicer to keep them separated, then take the square root. You'll see. We'll probably come across one, I'm sure, that works. So x is 6.
Can we just keep it the square root of 36?
No, if it's the square root of 36, absolutely don't keep it square root of 36. If it's a perfect square and it comes out to a nice whole number, you write it as a whole number, okay? Now, if it was the square root of 50 and you didn't want to write 5 square root of 2, I might let you get away with that. Okay, but if it's the square root of 36, write a 6, for goodness sakes. Okay, everybody should be able to do that. Everybody good with that? Okay, now let's do this. I'll do this in a different color. Let's solve for y now. Well, y is also a geometric mean. These three, this x, y, and z, are all geometric means. But they're geometric means between two different numbers. Okay, so we're going to get different answers for this. So y is also a geometric mean. How?
How would you do that? Because like the other one's like the altitude of the triangle.
Well, that's what we're gonna do.
That it is an altitude.
This is an altitude. Yeah. Well, let's just do this. I went through the explanation of how we got to this stuff yesterday, and I don't want to go through that again. You can just look at the video again if you don't understand. All I'm trying to do right now is just to show you how to do the problems, okay? Yesterday I went through the y's. Today I'm just showing you how to do it. All right, so here we go. The y's, haha. Okay, the WHY's. All right, let's do this one. Y is a geometric mean between what and what? Well, it's between the whole hypotenuse and the segment of the hypotenuse that's adjacent to that side. So between the whole hypotenuse, which is what? 13, and the side or the segment of the hypotenuse that's adjacent or next to or closest to that y. Which one of these is closest to y? 9 is. You see that? Because that's the rule, okay? If you really want to know why, look at yesterday's video. I do explain why, okay? I'm just not going to do that today. Yes.
So if it's not since it's not touching forward, then it would be 9.
That's right. Yep, and if you want to do z, you would use the 4 instead. You see that? So it's adjacent. Remember we talked about that word adjacent? Okay, so 9 is adjacent to y. I'm trying to use real geometry words here. That's why we learned the vocabulary some time ago, okay? And then you just solve. So here's where that little trick I was showing you over here, here's where it really comes into play. So watch this. I've got y squared equals, I'm going to go 9 times 13. Now you could put in a calculator 9 times 13 and get some number. I don't know, can you do that in your head? Can you do 9 times 13 in your head? You might be able to, but it might take you thinking a little bit. You could go 10 times 13 is 130, right? Take away a 13, right? But you don't want to do that, okay? Because look, watch what I'm going to do. I'm going to take the square root of this. I didn't multiply 9 times 13. I just kept them next to each other. Why did I do that? Because I've already got this separated. See how easier this is now? Are you seeing where I'm going with this? What's the square root of 9? It's just 3. What's this? What's left over? It's the square root of 13. And now it's completely simplified, and it was really easy to do that. That was actually easier than going 9 times 13, because I would have had to use a calculator, right? Well, I don't care what it is, because this is how I want it right here. Okay, I want it just like this. You understand? So I didn't automatically go 9 times 13. I saw the 9. I'm like, oh, I'm going to take the square root of it anyway. Let's just leave it a 9. Make sense? Okay. So let's do z. Z is kind of the same thing as y. Yep, so z is also a geometric mean. Alright, so z is a geometric mean between what? So let's put the z here and the z here. Between the whole hypotenuse, which is, and the one that's adjacent to z. What's adjacent to z? The 4 is adjacent to z. And you put the 4 here. Yep, and now you cross multiply. So exactly. See how easy it is now? You don't even have to go 13 times 4. You can just go, I'm going to go 4 times 13, take the square root, and z is 2 square root of 13. Wouldn't you agree it's a lot easier writing it in simplest form now? Yeah. Now this one right here it's about the easiest one you'll do, all right? Because it's all straightforward. All the variables right here are your geometric mean. So you're actually solving for your geometric mean. But sometimes they give your geometric mean as an actual number. Okay? And that's what we're going to do now. Alright, let me look at it first. Make sure it's the one. Okay, let's do 21. That looks a little strange. Now, we don't have much time, so I can't spend a whole lot of time explaining, okay? This doesn't look very much like a... That looks a little bit better. Oh, I'm sorry. I wanted to at least make it kind of look like it was a right angle. Okay, and this goes perpendicular, right, because it's an altitude to the hypotenuse. And then we get a 5 up here. This is an X. This is a Z. And this is a Y right there. And they tell you the whole thing is 14, right? So 14. We'll drop that down. Alright, here we go. You ready?
Yeah.
I'm just going to set these up just because of time limitations here. Let's, I'll just set them up and then you can actually solve for X, Y, and Z. So let's do, can we do X first? Because X is a geometric mean between the two segments of the hypotenuse. So X is geometric mean between Y and this unknown side right here. Yeah, how would you write this side? This would be 14 minus Y. But still, you got two variables and only one equation. You couldn't do anything, could you? So let's go another direction. Did you find Y? Okay. So let's use this then, right? Let's use that. Now, what is this? It's your, well, it's your, I've been using this word a lot today. No, this is what? This is your geometric mean. What is 5? That's also your geometric mean. What else? What's your other geometric mean? Z. You see it? But this time they give your geometric mean as an actual number, not a variable. So you're not really solving for the geometric mean. They give you the geometric mean. You follow me? So watch what you do. Good. So now you've got your two fractions, right? And then what's your geometric mean?
5.
It's 5. So you put a 5 and a 5. Between what and what? This is geometric mean between the whole thing, which is 14, and the segment that's adjacent to that side, which is Y. Now you can easily solve for Y. And now you don't even have any squares on this, do you? You follow me? You don't even have any squares. You just go 14Y equals 25. You do your math and you get Y. Okay? So we'll have to do that because we need to figure that out to figure out these other things. Is it 5.8? 1.8. 1.8. Okay, so Y is 1.8. How do we find this right here? What's that? 14 minus 1.8, which is what? 12.2, is that right? So 12.2, that little bit. And now you can find X now, because now you know these two, don't you? So now, right, so now you can find X. X is a geometric mean, right, between the two segments of the hypotenuse. So 1.8 and what? 12.2. Use your calculator for this. All right, this you're not going to be able to simplify. What is it?
I got 21 points.
Did you take the square root?
Well, that's after.
Right. I was talking to her. Right. So 4.7, is that right?
Yep.
Okay, so that's 4.7. Now, if you wanted to solve for Z, Z is also a geometric mean, isn't it? So we put the geometric mean here and here. Between what and what? Between 14 and the segment that's adjacent to that side, 12.2. Right? Plug it in here, do your cross multiply, and you get whatever you get for Z. What do you think? It's not so bad, is it? Good.
Do we have homework?
Yep.
Uh,
I just gave you the easy ones last night. Now we're gonna give you ones that really.
we didn't understand it last
But now
night.
you do. Okay, so your argument is moot. You ever hear that word? So here's what you're doing. Yeah, let's make it one big assignment. I might give you 10 points for it though. So 536, 537, and we're doing 26 to 37. There it is. So it's the same homework, all right? We'll put it on the same assignment. It's still section 8.1. I'll give you 10 points for it, all right? Remind me on Monday, though, to do that because I may forget. So we'll do 26 to 37. Same kind of stuff. I think they just pump it up just a little bit, okay? But it's the same kind of stuff.
I'm so looking forward to that.
All right, have fun with that.